Can you imagine living in a month without any electric equipment? No mobile phones, no TV, no fridge, no computers, no washing machine, not even a light bulb. Can you imagine how tough that would be? That is why we call that one of the most important inventions in human history is electricity. No matter if you're into sports, art, science, or anything else, having a basic understanding of electricity can be incredibly useful. It's like having a useful tool in your toolbox that you can use in various ways. There are two most fundamental concepts you must understand: voltage and current. It's no doubt that you have heard these terms earlier, but do you truly know what they're all about? Brace yourself, because by the time this video wraps up, you'll have a pretty solid grasp of these ideas. Everything around us is made of atoms. There can be millions of atoms in a tiny pinhead. Atoms contain electrons. Electrons are negatively charged, so they attract the positive charges and repel the negative charges. Usually, electrons are orbiting around the nucleus of the atom. That's the fundamental nature of an electron. Now here's the cool part. Some materials let these electrons break free from their atom buddies and glide through the crowd of atoms. Metals like iron, copper, and gold are the rock stars at this. Since these materials allow electrons to flow through the material, they're like electron highways, so we give them a special name: conductors. Since a small piece of material consists of trillions of atoms, there are trillions of free-flowing electrons in a small conductor material piece. And there are other materials that do not allow electrons to pass through it easily, such as rubber, glass, plastic. Since these materials do not like to conduct electrons, we call them non-conductors or insulators. This is a battery. A battery has two sides, positive and negative. The negative side contains a lot of electrons packed, and the positive side has a huge empty space that electrons can fill. These two sides are separated from a barrier that electrons cannot pass. As I mentioned earlier, electrons are repelling negative charges, so the electrons in the negative side repel each other, and it creates a huge electron pressure. Electrons are very much likely to move into the positive side that has less electron pressure. This less electron pressure side is the positive side. If we consider a battery alone, there is no way to release this pressure to the positive side. But if we connect a copper wire like this, since the copper is an electric conductor, the wire makes a path for electrons to go from the high-pressure negative side into the low-pressure positive side of the battery. So now the electrons are flowing in one direction from negative to positive. But there is no point in allowing electrons to go freely wherever they need. We are giving a path for electrons to flow from high pressure to low pressure, because we need to get some work done by their movement. Each of our electric appliances works based on these concepts. We create a path for electrons to flow from high pressure to low pressure, and we are powering up our applications using the movement of electrons. When electrons move in one direction, we call it electric current. But there's something funny. We say the current goes in the opposite direction of the electrons. It's just a rule we follow, even though it might seem a bit strange. We measure how many electrons pass by a spot in 1 second using a unit called amperes. 1 ampere is equal to 6.24 times 10 to the power 18 electrons worth of charge, moving past a point in a second. That's a lot of electrons. At the beginning, the electron pressure of the negative side is very high, and the positive side is very low. Since the electrons in the high-pressure negative region are moving away to the low-pressure positive region, the pressure of the negative side is gradually decreasing, and the pressure of the positive side is gradually increasing. After some time connecting the positive and negative side, the electron pressure between the two sides of the battery becomes gradually equal. So now there is no reason for the electrons to flow through the wire. So the current stops. We say that the battery has drained out. It doesn't have enough energy to keep moving electrons from negative to positive anymore. Electrons flow from high pressure to low pressure. To start an electron flow from one point to another in a circuit, an electron pressure difference is needed. This electron pressure is also called the electric potential. The electric potential difference between 2 points is called the voltage between those points, and it is measured by the unit called volt. The water tank analogy is a great way to make sense of electricity. Picture a water tank full of water and another tank that's empty. The water pressure increases as the water column gets deeper. Tank A has high water pressure, and Tank B has low water pressure. If we connect the two tanks using a water pipe, the water flows from Tank A to Tank B. The water pressure of Tank A is gradually decreasing, and the pressure of Tank B is gradually increasing. After some time, the pressure of the both tanks became equal. Then the water flow stopped. This is what happens in the battery. Water flow can be calculated by measuring how much water moves through the pipe in a second. The units can be liters per second or something similar. In electric circuits, we calculated the electron flow by measuring how much electrons move through the wire in a second. The unit is amperes. And we can measure the water pressure using units like Pascal or bar. Similarly, we measure the electron pressure in a circuit using volts. There is one last important concept we have to understand. There are two types of current that we use: direct current and alternating current. Direct current is simple. The electrons flow only in one direction. The negative and positive sides of a wire are certain. Battery is the best example that supplies this kind of direct current. The symbol for direct current is a straight line with a dashed line beneath it, like this. Alternating current is different. The direction of electrons changes rapidly. That's why it's called alternating. You may think it does not make sense, but there are many advantages to using alternating current. The negative and positive sides of this kind of power source are not certain. It changes periodically. In our homes, we are getting alternating current, so there are no positives or negatives to those wires. Even though we change the wires of alternating current, the devices still work. The symbol for alternating current is usually displayed as a wavy line like this. In alternating current, we have to define an additional parameter, the number of times it changes the direction of current within 1 second. It's called frequency. Now let's see how we can measure voltage using a multimeter. Keep in mind, we always measure voltage difference between 2 points. First, insert the black lead into the COM jack. Next, insert the red lead into the volt-ohm jack. Turn the dial to AC volt range if you are measuring AC voltage, and DC volt range too if you are measuring DC voltage. Place the leads to the points where you need to measure the voltage difference. Let's measure the voltage between the light bulb. We can place the two leads at point A and B. Since the battery is a DC source, we have to turn the dial to DC volt range. Then we have to place the two leads at point A and B. Finally, we can read the voltage value on display. Every electrical gadget comes with its own set of preferred voltage and current. You can usually find these numbers on a label. For an example, here is a label for a refrigerator. Let's see what the label says about the refrigerator. This symbol indicates it should be powered using alternating current. The voltage level should be about 127 volts to work properly. Since it's AC, the frequency should be about 60 hertz. That means the current changes its direction 60 times per second. Here it says it needs at least 2.4 amperes to work at maximum performance. Make sure to check the labels of your domestic appliances to find their power requirements before using those. You need to be careful and make sure to give the gadget the right type of voltage, AC or DC, the correct amount of voltage, and the proper amount of current. Now let's see what your domestic voltage is. Here you can see the information on voltages used across some of the countries. Feel free to comment on the voltage of your country as well. If you're going on a trip to different countries, it's really important to be mindful of the voltage used in those places.